this. There will be around 10 to 12 questions. Some of them has parts. The test will split into two sections. One section is you can use your scientific calculators, and the other sections you are not to use any calculators at all. If you don't have a scientific, make sure you bring your scientific calculators. If you do not have a scientific calculators, you can borrow it from me. The unit circle will be provided in the test. You can use this unit circle in both sections. And when I say unit circle, means it is just a unit circle, which looks something like this, where you will, the unit circle is just this, means it doesn't have any coordinates or anything. So just a plain unit circle. So you do need to fill in the coordinates on your own. And so this is provided in your test. You will start with the calculator section part first. And then after that, once you're done with the calculator part, you can come up front and exchange with the non-calculator part. And if you have time, you can switch back. Make sure you write your name on both tests. The calculator part consists of word problems. It is around 2 to 3 questions in there. So it's a very short calculator part section, calculator section test. The non-calculator is the one that is the longest one and the most points. This is the majority of the questions are in these sections. Example will be like finding the trigonometric remaining trigonometric functions given the conditions, graphing the trigonometric functions, inverse, verify identities, which we'll go over today's class, and then solving trigonometric functions. And this that I highlight in blue is new. So make sure you guys know this. This is very new. I just changed it just now. You are allowed to bring 1 page of notes in this test. And it's only the front page, means that and the size of the notes is going to be the normal size, not the super big size. So it's a normal size paper. And you can only fill in 1 page of these notes and make sure the back page is blank. I do not care if you want to type it out, write it out, how big, how small, what you want to do is up to you. So make sure that this is a 1 page of notes, and make sure the front page only, the back page is empty. Make sure you use the same size, not the super big one. Go buy a big piece of paper here. And up to you what you want to do with this page of notes. Again, you can type it out, you can write it out, you can write as big as you want, you can write as small as you want. You're going to bring a magnifying glass into class to read your notes. Please do so, but don't ask me what you wrote in your notes because I don't know what you put in there. So you are allowed to use that 1 page of notes during this test. And yes, you can use in both calculator and non-calculator parts. So please, tomorrow is a holiday. So please make sure you guys start writing this 1 page of notes, all the formulas or whatever examples, whatever you want into this 1 page of, you can even draw a picture if you want to. Or if you want, you're not going to do this 1 page of note, that is up to you. Okay, that is whatever you want, but make sure you guys know that that is 1 page of note you are allowed to use in this test. And the reviews we talk about. Yep. So please take advantages of this, and that is the most I can give it to you. Okay, questions with this test 3. Yes, this is new. So I just put this on y'all, and I will send it to you guys again for those who are absent for today's class, so you guys know what you guys are missing here. Questions with this? Okay, homework. There are 2 sections of homework due tonight, which will be 6.6 and 7.1. So these are a little bit tough here, and we did not finish 7.1. We will be finished 7.1 and we do 7.2. And then hopefully on next Monday, we'll do the solving trigonometric equations class. These are super, chapter 7 is a very difficult chapters, especially the whole chapter 7 at this point to you. Okay. Anyone have any questions for me in this 6.6 and 7.1? And again, we will do 7. We will need to finish 7.
Can we?
Calvin, yep, cannot hear what you said.
Oh, sorry. Question number 31.
On
7.1.
31. Probably will not go, we can go through it. Yep. 7.1, question number 31, towards the end there. Right. Yes, we will go through this in class today, but I will do this together. So since we do this, this question 31, if you look at chapter 7.1, is similar to number 13. Okay, so we're gonna do 31 and we will skip this 13. They are similar. Okay, because I haven't done that yet. So question number 31 is given us by 6√3 is equals to square root of 144 minus x squared, and x in this case is 12 cosine theta. So this is question number 31. So the question here is asking us, and then theta in this case is between negative pi over 2 to pi over 2. Okay. So this question wants us to solve what is 6√3 by using substitution. So we know that x in this case is 12 cosine theta. So you want to substitute this inside your x. So plug this in here. Okay. So what we have in this case is the square root of 144 minus 12 cosine theta and the whole thing squared. Okay, so we will plug this inside there. So this will give us, if you square this, you will get 12 squared is 144, and then cosine theta squared is become cosine squared theta. Okay, so what we do here is so you just square this below. What you notice here is that that you can factor something out. So this 144, you can factor it out. So when you factor 144, you will get 1 minus cosine squared theta, because they all have 144 in common. And then this 1 minus cosine squared theta, we can use Pythagorean identity. Okay. So so as you know that Pythagorean says sine squared plus cosine squared equals to 1. Okay. So what is 1 minus cosine squared? If you move this cosine squared to that side,
Sine squared.
This will become sine squared. So this is become sine squared theta. Okay. And now since we got the square root, so your answer in this case is, we know 144 is the perfect square of 12. Sine squared theta is the perfect square of sine theta. So in this case, 6√3, your answer in this case will be 12 sine theta. I think you might need an absolute value. Let's see if I need absolute value. Let's see, theta is this. You do not need absolute value. The reason why you don't, usually in calculus, you need absolute value here, because every time when you take a square root, everything has to be positive. The reason why you do not need an absolute value here is because your cosine is in this. So if you guys remember, what quadrant is from negative pi over 2 to pi over 2? What quadrant is this? So from negative pi over 2 to pi over 2, this is actually in quadrant 1 and also quadrant 4. So can someone tell me what happens for cosine in this quadrant 1 and 4? Anyone? So in 1 and 4, cosine is positive. So that's the reason why that you do not need absolute value. So this is your answer for question 31. So this is actually is 12 sine theta. So make sure the theta is in under symbol, I think. Yep, theta is right here. So this is how we do question number 31. Now you need to find how we do the cosine, how you find the sine and cosine theta for this case. This is easy. So once you get into here, so in order for us to find sine theta, you just divide this by 12. Okay. So sine theta in this case will become, so this will cancel, square root of 3/2. So for the sine theta is, now this is a special one because you will have two answers. One is √3/2 and the other one is negative √3/2. The reason why that this one you got plus and minus here is because it's back to the same quadrant, because in quadrant 1 sine is positive. And then in quadrant 4, sine is negative. So for this sine theta that we have, your answer in this case will be negative square root of 3/2. This is in quadrant 1, and then you will have the positive square root of 3/2. That is in quadrant 4 and quadrant 1. So that is the answer for the sine theta. In order for you to find the cosine theta, then you have to use your Pythagorean theorem, which is this friend of yours here. Okay, so we know that sine squared plus cosine squared equals to 1. So you just need to replace your sine square with √3/2. Now you do not need to worry about the plus minus. It's because once you square it, it becomes positive. So this will become √3/2 squared plus cosine squared equals 1. So this will give us 3/4. And then you minus 3/4 here to get rid of this. So solving equation here. So cosine square is 1/4. And you take the square root of it, and the square root needs plus minus. So your cosine theta in this case is 1/2. Okay, 1/4 is 1/2 of the root. This one you just need to take positive. The reason why you do not need to take negative is again back to this. This is all depends on this domain restriction we have here. So since quadrant 1 and quadrant 4 cosine is positive, so your answer in this case is just 1/2. So this is just 1/2. So this is how we do question number 31. Anyone have any questions? Okay. You won't see this in your test, so anyone have any questions for me with this? Okay. So this is 7.1. Oops. All right. Those who come in late, I just want to point out to you that in your test is next Wednesday. This is something new here is those who came in late, you are allowed to use one page of notes, only the front page during your test. So so make sure you guys have a page of notes, which is a standard size paper. You can type it out, you can write it out, you can write as big as you want, as small as you want. You can use this page of notes during your test 3, but make sure it's the front page, the back page is blank. Okay, so this is new. This is just I just add on today. So you can use this for both sections, both calculator and non-calculator part. So make sure you have that, right? We're gonna continue with question 7.1. So the question 31 that we just did here is him. Okay, so so we're gonna continue with more. So I think we start at number 8 last time. So we're gonna continue with number 9. So make sure this kind of questions want us to factor. So make sure you read the instruction really carefully what they want you to do. So if a question wants you to factor, and then you also need to use the identities. Again, your identities is right over here. These are all your identities that we'll be using. So so we start at number 9 and we will continue with number 9 here. So this is still 7.1 question 9. So question 9, you require to factor this below. So cosine x minus 2 over by cosine square x minus 4. So if you do not want to do this type of questions, then we just drop your cosine. So just do x minus 2 over by x squared minus 4 because you got the square in your cosine. Does anyone know how to simplify this type of rational expression? You need to factor. Anyone? Can we factor x minus 2? No, cannot factor x minus 2. Can we factor x squared minus 4? Yes, we can. And what's the factor for this?
X plus 2, x minus 2.
And then what can you do in this case?
Cancel the x minus 2.
And what you get?
X plus 2.
And now x plus 2 is 1 over x plus 2. So be careful. This should be 1 over it. So this is your answer for this case. So can someone tell me what can we do with number 9? So cosine x minus 2 is still the same as cosine x minus 2. So what is cosine square x minus 4? This will factor to become what? Cosine x plus 2 and cosine x minus 2. And what can you do with this? Very similar to this one, right? These two will cancel. So what you left? 1 over cosine x plus 2. So this is your answer for question 9. Questions, anyone? Number 10, cotangent cube x plus cotangent square x plus cotangent x plus 1. So again, the question wants you to factor. So this is the same thing, x cubed plus x squared plus x plus 1. So I just drop all my cotangent. It looks something like this. So can someone tell me how you factor this? You do it groupings. So what can you factor out in the first two terms? You can factor out x squared. You left with x plus 1. What can you factor out here? It's a positive 1. You will get x plus 1. So what is the factor for this? Since the x plus 1 is in common, so it's x plus 1, no square. So don't put the square here. Okay, there's no square. And then the leftover is x squared plus 1. So this is a factor for this. So I want you guys to go ahead and try to do question 10 on your own. Question 10 on your own. Anyone got what you get? What's a factor for this? Similar to what you have here. Cotangent. Henry? Ethan? Lukin?
Squared x plus 1.
Kevin, can you press on? I cannot. Cotangent what?
X squared plus x plus 1.
Cotangent square x plus 1. And what else? Cotangent x plus 1, right? Or the other way around. So this is not your answer yet because it's very similar to this one, right? And the reason why this is not your answer yet is because the cotangent square x plus 1, you can use identity to do it. So can someone tell me what identity can be applied for cotangent square x plus 1? What identity can be used on this one? So we can use the Pythagorean identity. So what is 1 plus cotangent square x? You get what?
Cosecant.
So you get cosecant square x, so forget the x square. And then you multiply this with cotangent x plus 1. So this is your answer for question 10. So what we do here mostly is we factor first and then apply the identities. Sometimes you do the opposite. You apply the identity and then factor. Okay, so you can switch them around. So as you know that if you find out every single one of this is the same trigonometric function, like here they're all in cotangent and here they're all in cosine, you do not need to change them because they all are the same. But if you look at question number 11, number 11 here will have cotangent square x plus cosecant x minus 1. So this question 11, you cannot factor this immediately is because there are different trigonometric functions. One is in cotangent and one is in cosecant. So we cannot say, oh, let's do like what I just did last time, x squared, blah, blah, blah. We cannot do that. So we have to change everything into the same trigonometric functions. So in order for us to do that, you have to use identity. Now, the only identity that I point out from Monday class is because this one have the square. So what identity can be used for the square one? We can use the
Last.
Pythagorean identity. So can someone tell me, this is the last one, yes, the third one. What is cotangent square x is using Pythagorean identity?
Cosecant minus 1.
So it's cosecant square x minus 1. And then what happens to this? You just rewrite it because we do not use Pythagorean identity on this fellow because there's no square. Okay, Pythagorean identity can only use if you have power 2. If it's power 1, you can either do reciprocal, quotient. That is the only one we can do if it's power 1. Okay, and then what we do here is now you find out that all these are in cosecant x. So we just combine like terms. So this is cosecant square x plus cosecant x minus 2 because -1 minus 1 is minus 2. Now you can factor this fellow. Anyone know what's a factor for him?
cosecant x plus 2 cosecant x minus 1.
Yep, so this is cosecant x plus 2 and cosecant x minus 1. Now this, we cannot use any Pythagorean identity because you don't see any square involved. So, you can change this cosecant to become reciprocal. What is the reciprocal of cosecant, anyone? Cosecant can change into what?
Sine.
1 over, right? So in this case, you can also write your answer as 1 over sine x plus 2 and 1 over sine x minus 1. So again, in this case, I'm not picky. As long as you can do one of this, I am really happy. So so make sure you guys got this. This is something that I recommend just leave it here. Don't change the sign because it makes the answer more geeky. Okay. So this is how we do question number 11. Okay. So again, if the question asking us to factor, so make sure you know how to perform factor, and if they are all the same trigonometric function, you can just factor directly. But if they are having two different trigonometric functions like this, then you have to apply mostly the Pythagorean theorem on the square one, and then you will get everything the same trick. So all will be cosecant or all will be cotangent in this case. Okay. Now the last one we're going to do in this section is 12. This is a fraction. This question wants us to write this not in the fraction form. That means that we do not want to have fractions in this case. So we don't want the 10x plus secant x in the denominator. Okay. So how do we do this kind of questions if the question did not want us to write this in a fraction form? We will have to multiply this by the conjugate. Okay, multiply this by the conjugate. So if a question changed from fraction to become no fractions, we do the conjugate. And yes, we do the denominator one. Can someone tell me what is the conjugate of tangent x plus secant x? Conjugate. Conjugate? You guys know what conjugate means, right? If I say 2 plus 3i, what's the conjugate of 2 plus 3i? Class, are you there? Ethan, Andrew, Henry. What's the conjugate for 2 plus 3i? It will be 2 minus 3i, right? So can someone tell me what's the conjugate of 10x plus secant x? What's the conjugate? (10x) minus secant x. So what do we do with this is you take the fraction 5 over by tangent x plus secant x, and you multiply this with the conjugate 10x minus secant x, the top one, and the bottom one, 10x minus secant x. So in this case, we are multiplying this with 1, okay, because these are the same. And you guys know that if you take anything multiplied by 1, you still get back the same thing. So that's why we call this as well-chosen one. Okay, so you will see this in the next section. So when I say well-chosen one, means that the top and the bottom is the same, means we're using the conjugate. Okay. So let's multiply this. So this, you will get 5 times tangent x minus 5 times secant x, because I just distribute my 5. This you have to FOI in your denominator. You need to FOI it. The good news is your middle term will cancel because one of them is positive, one of them is negative. So you will just get tangent square x minus secant square x. So when you void this, you will get tan square minus secant square. Again, we need this to become no fractions. So we can apply something on this denominator. Can someone tell me what can we apply on this denominator? It's an identity for sure. So we can actually apply what? Pythagorean identity here. So you can tell that majority of the time that you see here, we use a lot of Pythagorean identity. But which Pythagorean identity should we apply for this? 1, 2, or 3?
2.
So the second one. So if you look at the second Pythagorean identity here, it says that 1 plus tangent square is equals to secant square, right? This is the Pythagorean identity. How do you get tangent square minus secant square from this Pythagorean identity number 2? Again, you need to move around like doing equations. Anyone know how to get from here to there? What are you going to do with this secant square?
Subtract it.
Subtract it. So you get 1 plus tangent square minus secant square equals to 0. So I just want tangent square minus secant square. So what do I do with this one?
Minus 1.
Minus 1. So what is tangent square minus secant square?
Negative 1.
Negative 1. So this is actually negative 1. So I just, again, point out to you guys, the identity that you see here can be manipulated by adding and subtracting this Pythagorean, okay? So, so what we have is we apply negative 1 in here. So the 5 tangent become negative 5 tangent x. And the negative secant x will become positive 5 secant x. And you figure out that this is no longer has fractions in this case. Okay, so it's just a nice no denominator, no fractions. Okay. You guys all right here? So these are all the tricks that you learned in this 7-1. It's because as you look at the review for this test 3, none of the 7-1 comes out. The reason why is because what I usually want you to do in 7-1 is to practice this 7-1 and apply it in 7-2. Because when you look at 7-2, this 7-2 is where we do verifying the trig identities. So there are a lot of ways for us to verify the trig identities. First thing first, every time when you verify the trig identity, tell me which side you start from. Do you start from LHS or the RHS? LHS means the left-hand side. RHS is the right-hand side. So if you take geometry class in your high school, you should know a little bit of this LHS and RHS. So you have to tell me which one you start from. And usually we start from the more complicated side. So you got 2 sides, pick the one that is more complicated. If you can factor this, you factor it. Okay, so example will be like question number 8, 9, 10, 11 here. So these are all factorable. So I will recommend you to factor it. So this is like 7.1 question. The question that we just did now, 8 till 11. Okay, so again, class, in the test, I don't say factor it. So you have to know that this is factorable. If you have any fractions, you have to add fractions. This is like 7.1 question number 7, where you need to find the LCD. So this is very similar to number 7, this one. So when you have addition or subtraction with fractions here, in order for you to prove this, you have to find the LCD. So this is what it means by you have to add the fractions. Okay. If you have a square binomial, you have to FOIL it. So this is like 7.1 question 6, where you require foiling. Okay, we call it the square binomial. So it looks very similar to this one, number 6. So in this case, you see the square, you need to square the binomials, you FOIL it. Okay. Or create a monomial denominator. Now, this one is not in the chapter 7 one here. What is the meaning when I say create a monomial denominator? Creating monomial denominator means that monomial means one term in your denominator. So we want to make like something like this: 6 sine x sine square x plus cosine x. Let me delete that square here. And you divide this whole thing with a monomial, for example, cosine x. Okay, so if you manage to do this, what can we do here is this cosine x can split into 2. So you will get 6 sine x over cosine x plus cosine x over cosine x. So you can do this as long as this denominator is monomial. Mono means one term. If you have 2 terms, this is called binomial. You don't separate this. So do not separate this to become 5 over tangent plus 5 over secant. This is all going to be wrong. Okay, this is something you can only do that if you have only one term. You can split this. If you've got 2 terms, you can, or 3 terms, or multiple terms, you're not able to split this. Okay, so make sure you guys know this. So this is what we call as a monomial here. Okay. Next, make sure you use the fundamental identities. Mostly we use a lot of Pythagorean identities. Sometimes we use quotient. You notice that the sine goes well with cosine, the secant goes well with tangent, and the cosecant goes well with cotangent. The reason why that we are pairing this up really well is because of your Pythagorean identity. Okay, so if you look at your fundamental identity, sine squared plus cosine squared equals to 1. That's why the sine cosine pairs up really well. 1 plus tangent squared equals to secant squared. That's why this pair well. And then 1 plus cotangent squared equals to cosecant squared. So this is all paired up really well because of Pythagorean identity. And the last but not least is if you cannot do this proving, you can convert all the terms into sine and cosine. Okay, so if you look at your all these identities, your tangent and cotangent can change in terms of sine and cosine. Your sine, cosine, secant, cosecant can change to sine and cosine. Your tangent and cotangent can use this quotient. And then you can also tell that this 1 plus tangent, you can change this in cosine, is 1 over cosine square. And the same thing here is 1 over sine square. So you actually can change mostly these 3 identities that you see here can be changed into sine and cosine. However, this is the however that I'm telling you here is, if you do this, change everything in terms of sine or cosine, your work is longer. Okay, so if you want to change all your terms into sine and cosine, the work that you perform here is going to be twice or even 3 times longer. Those who use the identity or the like the rest of the ways. So yes, you can do that, but it's a longer way. And the last thing that we also can use is to multiply by the well-chosen one. This is the one that we just did just now, the one with question 12 here, where you try to change fraction to a not fraction. So this is so in this case, the well-chosen one in this case means the conjugate. Okay. So so this is in 7.1 question. I think what's the question we just did? 12. Okay. So so that is also, we can do that. So there are a lot of ways to do this verified trigonometric identities. There are something that is very important, class. So I want you guys to pay attention here. This is the one that I am going to really point out to you guys. Do not solve this. Do not solve it. Okay. The note here say, do not solve when you prove identity. Okay. What is the meaning when I say do not solve when you prove identity? Is, for example, like question 3. Oh, I do not want to do it this way. It looks icky. So I'm going to move this tangent x over there, become negative tangent x. You are not proving now. You're not verifying. You are solving, because solving means you move around. So so do not add or subtract, or do not multiply, divide. Oh, this all have 3. I'm going to multiply everything by 3. Do not cross multiply. So do not do this. Okay. So again, like this case, oh, I don't like this 1 over here. I'm going to move that negative 1 over there. Oh, I don't like this denominator. I'm going to multiply 1 minus cosine theta over there. Class, if you do this in my test, when I want you to verify and you try to cross multiply, you try to solve, then you prove it, and you will get 0 in your test, in the question. Okay, so please, when I ask you for verify, means your left-hand side has to be proved to the right-hand side or the other way around without moving your terms or without cross multiplying. Are you guys clear here? Do I got you guys' attention? You guys got what I'm trying to say?
Don't solve it.
Don't solve it. You're correct. But you also watch out. This is, so when you read the in my test, you will get what we call as verifying the identity. So when you verify it, please do not solve it. Okay. But when you do 7.3, which is the next section that you did on Monday, this time what we do, you solve it. So you will see the word solve. So class, this is something I want to point out to you here. So be careful with when do you not to solve and when do you solve. Okay, so when you verify, please do not solve. Otherwise, you get a big fat 0, which I will not happy, or you will not happy to see it. Okay. So now, some students ask me, is that a way for you to teach you? I will say you need to practice, especially verify identity. This is something that I cannot teach you. You have to like think, especially you have to think outside the box. So when I would strongly suggest you guys to do this written homework in your textbook, 10 to 45 question times 5 on page 522 for 7.2. Because if you just listen or try to do it on your own, I will tell you that you will not gonna do well in my test. A lot of students struggle in this test is because you guys need to really do this work on your own. So now I am gonna break you guys into 2 groups, and I want you guys to do the first page of this verified identity. So please take out your cell phone and take a picture of these 4 questions. Yep. And I'm gonna put you guys in groups. You guys have to do this and do not solve. Good, there are 6 people here. You guys are in 2 groups. So you guys ready? And I can share this with you. I will put you guys in groups and you have to do the work for me. Okay, go to your groups. Oh my God. So we did use a lot of this this reciprocal, this quotient and Pythagoras. Right? We use this a lot, but we never use this. So once you see something like this is your left, this is your right. When you see something like this, where you have the pi over 2 or 90 degrees, this is where the core function's identity is used. Okay, again, pi over 2 is the same thing as 90 degrees in radian. So can someone tell me what is the core function of tangent pi over 2 minus theta? Which one are we using here? We are using this one. Tangent pi over 2 minus theta is actually this one.
10.
Called tangent theta. And then we will multiply this with a tangent theta. And don't forget, our goal here is to get what? To get 1. So can someone tell me, well, how do we multiply this to get 1? What kind of identity we use? We can look it.
I said the reciprocal identities.
So the cotangent can be used, or tangent, one of this. So make sure you change one of these, not both. You can use what's the reciprocal of cotangent?
For cotangent, it's 1 over tangent.
Okay, and what happens when you multiply this with tangent theta?
It makes 1.
It makes 1, which is the same as the right hand side. Okay. You guys all right here? Do one more. We got. So class, so when you see this is a big hint saying that we're going to use the core function. I know we don't use core function a lot, but there is, once you see this, it's very obvious if they're using core function identity. And let's do the last one, number 7. Ooh, this is fun. Cosecant x plus cotangent x equals to sine x over by 1 minus cosine x. Can we use Pythagorean theorem on this question?
No,
Why not, Kelvin?
there's no square.
There you go. So there's no square. Please do not use your Pythagorean. Anyone wants to give a try? This is actually very tough.
You want to do the right side?
Okay, we'll do the right side. So what can you do with this right side?
You make it into 1 minus tan theta.
Where you, the right side? You cannot split this into 2 because this is a binomial here, 2 terms.
Okay.
So you can only split it if you only got 1 term. Okay. Anyone? Good try, but anyone? So this is actually 7 is really tough. So if you look carefully, this one is this one is a fraction. So you remember today class we changed a fraction to become a non-fraction. So how do you change a fraction to become a non-fraction? Conjugate, right? So what is the conjugate we have for the right hand side here?
1 minus cosine x.
No, that's not the conjugate.
Plus.
This 1 plus cosine x. Okay. And then the bottom one also is 1 plus cosine x. So in this case, we do need to multiply by its conjugate, or sometimes we call it the well-chosen one. So the top one, I remain the same. I'm not going to distribute it. So it's going to be sine x, 1 plus cosine x. I don't want to distribute. Last time I distributed a 5. Then this one, I just did the same. What you have in the bottom here, anyone? When you FOIL this, is 1 minus cosine square x. Right? Again, when you void this, the middle term will cancel out. So you got 1 minus cosine square x. Can someone tell me using Pythagoras? Now you can use Pythagoras on this one because you got the square involved. So what is Pythagoras? What is this going to give us? One minus cosine square x.
Sine square.
So this is sine square x. And what can we do with this sine and the sine square here? Well, this is factor. You can cancel that. Okay, since that's why I don't want to distribute because it's a real factor. So this is cancelled, but this sine square, you cancel only one of this power. So what we left in this case is 1 plus cosine x over sine x, because the square become 1. And again, this is only one term. So this time, this one term you can separate into 2. So when you separate this into 2, you get 1 minus sine x, 1 over sine x plus cosine x over sine x. Now, can someone tell me what is 1 over sine x is?
Cosecant.
This is cosecant x. And what is cosine plus sine? Cosine over sine.
Cotangent theta.
Cotangent x. And this is the same as your left hand side. You guys all right? Super tough, yes. Practice, absolutely yes. A lot of students struggle in this class until here, they struggle because of this, okay? So I do want you guys to do the last 3 exercise here, which I did not do, which is question number 8, question number 9, and question number 10. I do take attendance. Do I take? Yeah, Kelvin, thank you. I'm going to take attendance here. So I think I know you guys already. It's recorded. So I want you guys to try number 8 and number 9 and number 10. The hint is number 8 is left hand side is 1 term. If you look at your left hand side, this denominator is 1 term. So the hint that you're going to do for question 8 here, so I'm going to give you a hint because in the test there's no hint. So question 8, the hint is you will start from the left hand side and you have to, it's a monomial denominator. So you have to split this into 2, okay? Number 9 and number 10, I will recommend you guys to factor, okay? Number 9 and number 10 is factoring. So number 9, you can tell that you can factor something else. Number 9 is you start from the right-hand side. Number 10, you will start from the, let me see, that's all powerful. Number 10 is not factoring. Let me see. Number 10, you start from the left-hand side. So number 9, the hint is to factor it. Number 10, you can tell that all this is in cosine. The only thing that's not in cosine is the sine. So in number 10, you have to write the sine 4x in sine square x times sine square x. Because sine 4x is sine square times sine square. And then you have to use Pythagorean identity twice here for each one of this because they are squaring. And you will end up with the right hand side here. Okay. So this is a little hint for you guys. There are notes in my in D12, so I would recommend you to try these 3 questions. So when you especially this weekend, this is something you guys need to practice really hard. And then when you come back on next week, we will talk on Monday, we'll do 7-3, and then your Wednesday will be your test. Okay. Again, to just remind you guys, your test, you're allowed to bring 1 page of notes, front page only. Okay. Right. Anyone have any questions for me here? Attendance is taken. Good. You have no questions.